Hello, everyone.
We're going to talk about micro frontends. I'm Christian. I do IoT stuff, React stuff. I think that's enough about me. I'm Christian. Just call me Christian or Moodiku, whatever.
I'm Elmar. I am a front-end developer at Blendle. You can check it out. You can read articles online there. You can reach me with via different channels, but we have not that plenty of time.
Blendle is cool. Check Blendle out. Okay, let's talk about micro frontends and reasons why you might want to introduce micro frontends and what micro frontends are and how to implement them. And
who of you had ever heard of micro frontends and is interested in it? That's quite a few.
Is one of you working with Neuland? Holy shit, that's like 4 people. You're going to recognize some stuff. Okay, why are we talking about micro frontends? Micro frontends are a topic to, or are an answer to the question, how do we structure the development of our web applications? There are some traditional approaches on how to do that. The most traditional and most common or oldest or whatever approach is this. If we develop an online shop, we have one monolithic application that handles everything. It contains our HTML, our JavaScript, CSS, PHP, Java, whatever you do in the backend. That's just one team that develops this application. At some point, someone might have realized, okay, the team is getting bigger and structuring it as one team and one application doesn't really work out so well. So people start to split it up. And the easiest way and the most obvious way to structure or to split up a development team is to realize, okay, we have backend developers, we have front-end developers. Let's make a backend team and a front-end team.
Who of you is working in this team setting? It's the most.
Okay, interesting. At some point, some of the backend problems might become bigger, and the backend team quite often becomes the bigger team. And at some point, you have like 5 front-end developers and 25 backend developers, and then you realize, damn, again, we're having a team of 25 people, and that doesn't scale. So you start to split up the backend, and there's this microservice thing that people have been doing for ages now, or even before that, they called it service-oriented architecture, and that was basically the same. But okay, so this is a very, very naive approach to say, okay, the backend team becomes bigger, so let's split it up. But I don't know if you know the year, but it's 2018, and maybe we're having a front-end application that requires more than 3 or 5 developers, but maybe we have a front-end team of like 20 developers. Or maybe we've heard of a term that was called cross-functional teams, where we say we should not split up the team in a product management team, in a designer team, in a front-end team, in a back-end team, but instead have a team for every part of our application, for every part of our business domain. And that's why at some point people started to use a different approach. This is sometimes referred to as self-contained systems, which comes from the DDD world. Never mind that part. But the approach here is to say, okay, we have a team, for instance, if we were talking about a web shop, Team Inspire. They are responsible for suggestions of new products. We have a Team Search. They're responsible for the search. Team Checkout, obvious what they do. And the team is responsible for both the front-end part, the back-end part, everything that's there, the product management part. That's one team. By the way, I asked about Neuland before. Neuland did this website, microfrontends.org. This picture is from microfrontends.org. Didn't it say it somewhere in the slides?
It was on the first slide with
a sorry, I forgot to mention that. It's under an open license, that's why we can use it. It's a cool website. So we didn't make up the term microfrontends. I think Neuland didn't either, but yeah, they made this cool website. The question is, why do we want to do something like this? I mentioned reasons for it, but there are several reasons why you want to do this.
Exactly. One reason is that what you mentioned, the team is growing and you have too much developers in one team and you have to split up the work. You can do it by either making a lot of Trello cards or Jira tickets or something like that and let developers work on different domains, but this don't often work out very well because you have special domain knowledge needed. Another reason could be that you want to deploy your product or your front end or your product separately. This could be a reason that you have different speeds, you have different sprint times, and you want to release more often, for example, but your main product is released once in a month. Then you can split up the front ends and you can deploy the products separately. Another idea could be that you want to isolate your runtime. This could be very different reasons. For example, you have a payment service and you have to collect special data from a payment service provider, and you have conflicts normally with privacy, but for a payment you have to do it. So this could be also a valid approach. And I think the most important reason to split up micro frontends is that you have one legacy application and you want to modernize it, but you don't want to do a big bang migration that you have to throw away all the code and rewrite everything. With a micro frontend, you can modernize the application piece by piece, and then you have one small part that is new and the big legacy part, and you can migrate this big application step by step. But the question is,
if we have reasons how to do it, how do we actually do that? And there are several approaches that we want to mention, but the question is, we now have a problem. What's the obvious solution? It's these days always the same. Blockchain is always the solution to every problem, right? We're missing a blockchain talk at this conference. I mentioned it before. Not that I'm a fan of it. Okay, no, getting serious again. What are solutions on how to implement micro front ends? One way is to have a shared runtime where many front ends run within the same runtime. Or we can say every front end has its own runtime. There's also like a mixed approach that we're going to talk about. Let's get started with the own runtime. How do we separate runtimes of applications? Well, we're in the web and there's a technology that's pretty cool. We just reinvent the wheel and use hyperlinks. So we have one application that is called, in our shop example, the Inspire page. So we have a website, let's say inspire.theshop.com, and on that page we can see new products. Then we have search.theshop.com, and we can find products there. And then there's the product website, products.theshop.com. The first two just link to this products.theshop.com.
One approach you see very often in web shops is that you also have a payment page separately, because you run through the checkout process, you come to the payment point, and then you do one special thing in one of these runtimes, in one of these front ends.
And that's actually pretty cool because the runtimes are completely separated. I mean, in a case of an online shop, let's be honest, that probably doesn't work that well.
I can tell you, we at Blendle have done exactly this example. We have put out our payment service or our payment page into a different front end. It was quite a big work, but now it's a huge benefit to have exactly this setup.
Again, for Blendle, it makes sense. I think so. Payment, you said, also landing pages, right, are separate.
Exactly.
They're completely separate from the rest of the application, so it makes sense to take them out because then it's easier to decide, okay, with the landing pages, we want to use the next big thing in web technology. And that's what you exactly did, right?
Yeah, we used Next.js, so the next, yeah. You have different approaches and you have different goals to achieve with each project. For a landing page project, for example, you want to achieve the best marketing possible. So you want fast page renderings, you want server-side rendering, but you don't want it in your big application where users authenticate because it makes so much headache to implement this. Then you can skip it. For a payment service, you have completely different things you want to use. So different projects and different goals to achieve.
But again, the reality is not always like this, right? So there might be situations where we have different teams developing different micro frontends, and this all should be on the same page. So we want to have multiple applications running within the same page. And again, thanks to Neuland for that image. What we have here is a web shop, and let's say that this web shop is developed, consists of multiple micro frontends. We have the buy button here that's from one application. The green box is obviously from Team Inspire because they're responsible for suggesting new products to customers. And then the outside is, Team Product again, I think. You're not supposed to read tweets while we do talk. Sorry. If we have an approach like this, if we have a website like this and we split our teams like we suggested before, all these teams have to run within the same scope of the website. And this might work if we have, for instance, a team that does React, a team that does Angular, a team that does Vue.js. Then we could run this all in the same application, in the same DOM, in the same JavaScript scope, and it might actually work. there might be some obvious problems that we're going to talk about later, but you could do that. If you instead have multiple versions of the same framework, say React 14, 15, and 16, and you run them on the same page, you might run into problems because they all want to define the global called React, or some libraries there use the same global variables. That actually happened to us with a React micro frontend application, and they had the same version of React, but still had problems. And then there's a way on how we could actually implement such a page that consists of multiple micro frontend applications by just putting iframes there. That's something I was expecting laughter. That's fine. The thing is, iframes might not be as bad as you think. Iframes used to be very bad, and we hated them. I mean, frames used to be even worse, right? But there might be reasons why we would want to use iframes here. They're perfect because they give us the separation of if we would run on multiple domains. We can actually run on multiple domains, but just include them with the iframes. So it feels to the user like they're using one big application, but in truth, you have multiple applications. Of course, if you have like 20 iframes that include 20 other iframes that include 10 other iframes, you might run into problems, of course. But if it's just what you mentioned before, the payment, and you have the payment button that should be included with one other application, then it's totally fine. At least if they don't have bundle sizes of 20 megabytes.
But no application should have that, of course.
Right. So again, if you can do the iframes, that's a super cool approach because you can integrate it for the user. It feels like it's one application, but in truth, you have completely separate runtimes. That's you.
Okay. Yeah. So if we want to achieve this example of different versions of on tools on one page, this is possible actually right now in the browser. Imagine we use a tool that we all have in our hands or on our laps, like a browser, and we all know HTML, or at least we know a little bit of HTML. And in HTML, we have something that is called input. Input with a type, datetime local, because I couldn't make a screenshot of it, but it will make a calendar to choose a time and a date with this tiny piece of code. It will look like something like that. What if we can take this approach to something for our micro front-end idea, that we just have an element we can place somewhere, for example, checkout button, and use it in the place we want to use it in a shared runtime. So we can define our own elements with an, I hope it is a little bit readable, with an API that is called custom element. Actually, the custom element version 1 is the most current one. It's implemented in Chrome and in Safari, also on iOS, and is about to be implemented, or nearly ready. It's hidden behind a flag for Firefox, and it will be implemented in Edge. You can define elements by yourself. If you ever have done Angular version 1, you maybe know how to define an element. It's nearly the same. Here, you define a class with a constructor which will be called when you use the element, and you just define the element that you want to be used. With this, you can. It's nearly not readable. You can put properties into it and just use the HTML element.
And that means behind that. Okay, now I know why you wanted to fall down here. Behind this element, you can hide whether it's a React application, whether it's a Angular application, whether it's a Vue element, whatever. You can just encapsulate it in a custom element, and then no one will know what you use behind the scenes. And you can change the implementation completely as long as you stick with this contract.
And the good thing is that you can hide everything behind this element, is that you can use a completely different other framework. I mean, we all do JavaScript, and we all use plenty of frameworks. So I want to introduce a new framework that's called Stencil, Stencil.js. It's built by the Ionic team, and it's exactly what it's exactly for custom elements made. So it uses the web component or the custom element API under the hood with a concept that looks like Angular and that looks like React. So if you have Angular, if you have done Angular, this code will look like Angular for you. And if you have done React, it will look like React for you. You define the tag and you can define styles and everything is included. It's also fully reactive, so if you change a property, it will react to it. It has a virtual DOM implementation and all the cool shit implemented. It is written in TypeScript and you can compile it. It's really awesome. We have it in production since yesterday at Blendle. So I can really recommend this tool. It also can come with server-side render for applications. But you don't have to use something like Stencil for these component things. You just can use the tools you have already. Like Christian said, you can use React or Angular. Angular version Grader 2 will come with Angular element that do completely the same.
Okay, so we mentioned on why would you do that, how do we do that, what are implementation details. But for us, it's always important if we talk about something to mention what are the downsides. Because even if we have to scale a team and microfrontends might help us, everything comes at a cost. One obvious thing, which you probably got when I was talking about the iframe within the iframe within the iframe, are bundle sizes. It might be a problem, obviously, if you start rendering within one page multiple applications in iframes or using custom elements, but one of them uses React and the other uses Angular, you have big bundle sizes. That might be a problem. It might be okay if you're like developing Spotify and you have the downloaded Spotify app anyways. It doesn't matter whether it contains 5 megabytes of React and 5 megabytes of Angular because people are going to stream a lot of music with it anyway, so who cares? It also depends on the approach that you take. If you have like Blendle does that, the shared runtimes, the payment page that you visit like once a month maybe, and the landing page that you only visit once in your lifetime probably. And then the real Blendle application, it doesn't really matter if all of them have a bundle size of 5 megabytes because you usually only use one of them.
It does matter especially for a landing page for marketing, but
Sorry.
If you have something like Service Worker for your main application, for your core application, it doesn't matter that much.
Also, if you're doing one of these shared runtime approaches, one thing that I mentioned before, we're having this React application that actually consists of multiple React applications. What we do there is that most of the React libraries are only loaded once because we just use the same version of React, React Router, React whatever, so we only have to load them once. So that makes stuff better. You can improve stuff there, but you should take a lot of care, obviously. And yeah, I mentioned it before. If you're doing the iframe approach, things might get very, very dirty very, very early because if you bootstrap multiple applications on the same page, that's going to be a lot of bundles. Also, it's going to be a lot of memory because you're going to have 10 instances of React and 5 instances of Angular and 5 instances of Vue running on the same page. So I don't know, old cheap Android phones and old cheap iPhones might have problems there. Again, there might be situations where it works, like the Spotify player I mentioned before, or the service workers, which might help as well. One big problem is consistent look and feel. If you have like 10 teams, they're developing 10 front ends and they're somehow integrated, like with iframes or however you want to integrate them, even with a shared runtime approach. If team A decides, okay, that button becomes green now and has been blue forever, the rest of the application probably still has the blue button. That might be a problem. So the question is, what do we do to make sure that the button always has the same color? One approach that actually an attendee at a conference mentioned to us like 3 weeks ago, is pretty straightforward. We just don't care because the user won't care if the OK button is sometimes green and sometimes blue. There's this American startup in e-commerce, they're called something like Amazon. I don't know if you've heard of them.
the river, yeah.
Yeah, sorry. If you look at their webpage, it's unbelievable inconsistent. Go to the settings, or even worse, go to Amazon Business settings, and everything looks, I don't know, like an HTML page that's 15 years old. So there might be reasons, might be situations where you just have to, you can ignore it. And maybe you make the button green at the other applications 5 months later, that's fine.
You have some different startups like Facebook that also change buttons often, or glasses. No, Google is it. Google also have different buttons on different pages if you dive deeper into an UI. I mean, if you ever have used analytics, Google Analytics page, it's a hell of inconsistent UI, but it just works.
And it makes a lot of money, right? So it can't be that bad. But of course, we have like real solutions that are not saying, ignore it. Another approach, actually we skipped that shared CSS thing, right?
Yeah, we skipped
so
that shared
I'm going to
CSS.
say that you can have one big CSS file for all your micro frontends. If you're good at CSS, I'm not, but if you're good at it, you can do that.
Something just like Bootstrap is doing. You have one CSS and reuse the class names everywhere. But another approach is to have a component library, a UI component library. You can use the micro frontend idea and the custom element idea to build reusable components. Just we saw earlier with the input element, you can build your checkout button, your company checkout button, in a shared component library and reuse the same UI everywhere in every project. The nice thing is you don't have to reinvent the wheel every time. You have a dialog component and you have your main components, your main UI components somewhere defined. Also, this helps to communicate with designers. Then you have one file, a kind of style guide, where everything is defined. And if a designer comes around with a new design, you just can use the existing ones and check with him, maybe to use existing ones.
That's actually something that's very, very easy if you use the same framework within every of your micro frontends, because then you can just like expose React components in your UI component library, or you can expose Angular elements in the UI component library. If you're mixing it, again, it gets more complicated, but we heard about the custom elements API before, so I think you can do it even if you have different libraries.
Just keep in mind that if you have a shared library, that you want to be sure that the version of your library don't have breaking changes, because once you change the API of your UI elements, every other micro frontend will break, and you have to fix it manually.
That's why I would always say, if you're developing such a component library, have like the strictest code review process in place for this library. And just like an open source library, use semantic versioning, do not break BC like ever. And if you do, talk to every team that uses the library. That's the only place where you're allowed to break BC in these component libraries.
And use tools to automatically update your dependencies and to check the dependencies. I've heard it in every talk I was today, it was two, is use something like Greenkeeper or something like Renovate to automatically check, put in pull requests into your code base once the dependency updates. It's also the same for own dependencies. Use a UI component as a module and automatically update them.
One thing I want to mention, I said, take care that it's that there's a strict code review process in place for changes to the component library. There's a problem if you make it too hard to update the component library, to add new stuff to the component library. People would just implement the components within their micro frontend and not contribute it back to your shared component library. So that's really something that's not going to be easy. Mm-hmm.
Once you have a component library, you should build something like a kitchen sink, a component library example page. You can use something like style guidist if you're using React, or you can use Storybook if you're using Polymer or Web Components, React or Angular.
Or Vue.
Or Vue is also usable.
I think it's also usable with Vue.
If you use one of the major frameworks, then use Storybook. Both of these tools are awesome and can help in the process. Also, you can show every case that is possible with your component.
One thing, we're talking about sharing code here between multiple micro frontends using a component library. And some people will tell you, if you're doing micro frontends or microservices or self-contained systems or whatever, do not share code between them. So do not create a component library like this. We disagree with this. There are things that you shouldn't share. I think in the self-contained system world, people are agree on the fact that you should not share business code. But stuff like UI components, as long as they don't contain business logic, that's fine. Or tooling, that should be fine as well.
You don't want to implement the user query every time in every project, in every micro frontend you have. You want reusable stuff for this.
Yes. There's one thing, my favorite topic that I always rage about when I talk about JavaScript. Who of you likes to maintain Webpack configuration files? There are people who like that, like 4 of them. Oh, 5, sorry. Yeah, the thing is, if you hate configuring them, maintaining them like I do, I really hate that. You now have to do that like 17 times, right? Because you now have 17 micro frontends. So you really have to invest into tooling. You mentioned Greenkeeper before. That's very, very good to have that.
Also, if you don't use, maybe you use different package manager in different projects. Maybe you have Gulp, maybe you have Rollup, maybe you have Grunt, maybe you have next big thing, JS Parcel, I don't know. You can use all of them, but make contracts between teams that you use the same tools for every project you have.
That might make sense, because otherwise, yeah, knowledge will be spread completely weird.
One important thing you have to think about is routing between front ends. We just mentioned that we reinvented the hyperlinks between different DOM states. Also, if you navigate from one to another micro front end, you want to preload stuff, so you want to make sure that it is working in a correct way, just on the client side. But also, you want to have something on the server side that make routing to different front ends on different paths much more easier. You can use something simple like Nginx or an Express server for that, but there are more complicated stuff out there. You can use it. You find it if you search for routing on micro frontends.
And obviously, if you're using like the shared runtime approach where you're using React, Vue, and Angular on the same page, you can't just use Angular router because, yeah, you also need to support React router somehow. Or you develop your own router, because developing your own library is always a good idea, right?
Irony.
Thanks. Okay, so again, the conclusion. Micro frontends might help you big time. We have kind of different opinions on when you want to introduce micro frontends. For me, it's always a question of if your team is getting too big, then they might really, really help you. If you're modernizing applications like Elmar just mentioned, then it's really a big help, because even if you have this big old XJS 3 application that some companies still have, you can, someone is laughing. Not the one I was talking to, actually. He didn't start laughing. Okay, then you can just start developing your new components with React and integrate them to your old application, or do it the way that Blendle does. This all works, and it helps you a lot, but it comes at a cost. Again, 17 Webpack configs, right? So always introduce new micro frontends with care. I've seen projects that have like 10 to 15 micro frontends for like 3 front-end developers. That usually hurts a lot. So take care when you introduce new micro frontends.
Just be sure that you don't implement or just add new complexity to because it's cool to have micro frontends right now. Always check if it is needed. And mostly it's when you want to modernize your application, then it's a really good way to add new micro frontends. Don't forget, if you modernize, to throw away old code. That's the most important thing. Always keep in mind that throwing away code should be the best way when you review a code. Make sure that the code is removable later on. This will help if you want to implement micro frontends once in a time, maybe in 5 years.
So if you use micro frontends for, like you mentioned, the legacy or the modernizing of legacy applications, and you start with the XJS monolith and start the new React application there, if you then decide, okay, we want to go with Vue.js, then maybe don't set up the third micro frontend with Vue.js, but try to get rid of one of the others first.
Or just start a new micro frontend with React, because you have it already, or
right.
with XJS 3.
That's actually all of our content. I think we have like 3-4 minutes left for questions. Are there any questions about this topic? There's one, yes.
How do you synchronize loading of iframes, like to avoid links and so on?
I didn't get that word. How do you synchronize what?
Loading of iframes.
Yes, that's an interesting thing. That's actually something that I just experienced in an application where people had problems with that. So What we do is we have quite a lot of events flowing between the iframe and the outer region. So we have this placeholder image that's rendered before the actual content of the iframe is rendered, and at some point the iframe is going to send okay, I'm done rendering, and then the image is replaced with the content of the real iframe. Does that somehow answer your question? Great. Other questions? Or do you want to add something? Sorry.
No, there's different right.
How do you share what? State? State.
Yeah. If you want to share state, you always want to make sure that it's the lowest level possible. Mostly it's something like a refresh token or a JWT, and you want to build up the state by your own because you have your own state management library in every other language. If you have one state management library for multiple languages, something like Redux or something like MobX, then it's possible to use the same state library and just swap out the UI part. It heavily depends, but mostly you want to go down as much as possible and don't share any state between them.
That's exactly what I wanted to say. So you mentioned JSON Web Tokens, or let's say the information about the current user. You may share that state. If you want to share more state, then probably these two should not be two different micro-frontends because they're responsible for the same business domain. So they should actually be one application.
One last.
How do you make them communicate with each other? It totally depends on the approach. So if it's the iframe approach, you can just use this post message API. Is that the name? I think it's the name, yes. If it's in the shared runtime, you can have a central event bus there. What we're doing with a separate runtime thing is that we have an event bus in the back end, and some of the events are actually transferred to the front end using WebSockets so that they can communicate using that. What is important there from my point of view is have a defined contract on what is allowed as a communication. I experienced one project, they just threw Redux messages, Redux actions into the Redux message bus, and nowhere there was any documentation about the messages. Someone just assumed, okay, if the message is called add user, then there's probably this property. That's going to be a hell. So if you communicate with each other, define a contract there.
There is also a good library from Zendesk. It's called shared storage. It's something like local storage, but for different domains accessible, which works very good for if you have different runtimes. I think.
And there's one last question. What is universal rendering? Is that backend, server-side rendering and front-end rendering? I'm not sure right now.
Yeah, if you want to have universal rendering, you have to stay with one framework, and you can't mix the different front ends in between. That's not really possible. Or
integrate it in the web server. Like if you have an Express server, then you could do weird stuff there.
You can do weird stuff, but it's hard, and it's manual work. It's not really something that works out of the box-ish like React Render or Vue of Angular, or I don't know.
If there are further questions, we're going to be here the whole day. We're going to be at the party tonight. Just come to us, talk to us on Twitter. I think our names are there. Yes, they are. So thanks a lot and have a lot of fun at the JSUnconf.
Bye.